Hello everyone, welcome to the another very important session in which we are going to talk about some more important questions and the concepts for our upcoming CSIR net and the GATE physics exam. So guys, I hope that the discussion which we will be doing today in this session will be getting clear to all of you. But in case if there is anybody having any doubt anywhere, you can surely let me know about it. So we will be starting the discussion about the condensed matter physics in this session. Also guys, if you want to know about the latest offer which can help you to save more in the total Unacademy subscription amount, so here is we are gonna have this slide which will provide you the information about the latest offer, and this offer is valid till 12th August. So just to grab it, you need to use and apply the code Anjali A Live as mentioned here on the screen. By using and by applying this code, you will be able to get the discount in the total subscription amount, guys. Also, all the details have been shown here. Even if any of your friends want to take the subscription, you can share this information with them, let them know about the code that is Anjali Live to get the discount in the total subscription amount. Okay, now let me just quickly show you what are the benefits you will get if you will be taking the Unacademy Plus, Iconic or the Lite subscription. Also guys, all the details have been shown here. Along with that, even now the important notes are available on the learning app, which will be helping you to do the best preparation under the guidance of top educators with well structured and well planned courses. And if you will take the Plus, Iconic or the Lite subscription, then what are the benefits you will get? All that has been shown here on the slide. So depending on whichever you are going to find more beneficial for yourself, you can take that subscription. Okay, now here I'm going to show you a few more slides and we'll go ahead to start the discussion about the questions then. So this is about the Unacademy learning app. This is about the session. This is something related to like details about me. This is about the community feature which will help you to stay updated, to know about the latest information and all that. Now we are going to discuss about the important questions today in this session from the condensed matter physics. We will be taking the questions from different sections, guys. So in case if anywhere you will have any doubt, you can tell me. I'll consider that part. But if everything will keep on getting clear to you, that's gonna be great. Okay. Let me just write the first question. And as discussed, if you will be having any doubt anywhere, you can surely mention it. Okay, here is our first question, guys. The dispersion relation for a one-dimensional monoatomic crystal with lattice spacing A lattice spacing A. Next is which interacts nearest neighbor harmonic potential is given by this, where A is the constant is a constant of appropriate unit now the group velocity like its parts we are gonna have for this question. At the boundary of the first brilliant zone is options are 0, 1, square root a square divided by 2, 1 over 2 square root a square divided by 2. So you just have to consider which option is correct and you have to work on finding the group velocity at the boundary of the first brilliant zone. Okay, just work on it and tell me what is going to be your right answer for this case then. If you will not get it, I'll help you guys, don't worry, but I want you to try it first. So omega is given and you have to find the group velocity at the boundary of the first brilliant zone. First brilliant zone boundary exists at k is equal to plus minus pi by a. Okay, and group velocity formula is d omega by dk. That's what you have to consider. Solve it now, guys. So when you're going to differentiate it with respect to k, the sine part will become cos and the k by 2 will be present in the starting. Like with respect to k, you are going to differentiate. So a by 2 will be in the starting. So capital A, small a by 2 and the sine will become cos, right? So that will be when you are going to apply the limits k is equal to plus minus pi by a. So that will give you pi by 2. Cos pi by 2 will be what? 0. And your right answer is option A, which is 0. That's how you are going to solve it, okay? You just have to find d omega by dk and then the boundary exists at this. So when you are going to plug in this value, you are reaching to your final answer. You can tell me if in case there is anybody having any doubt, we can consider it, guys. But if it's getting clear, that's great. Let's take the second part of the same question. So second part says the force constant between the nearest neighbor of the lattice is where capital M is the mass of the atom. M a square over 4, M a square over 2, M a square, or simply it's going to be 2M a square. That's what you're gonna have. Try it now, guys, and let me know if in case there is anybody having any doubt. So same question, same initial part, just you have to find this time the force constant between the nearest neighbors. So this is basically the question from the lattice vibration part. In this case, they are talking about the 1D monoatomic crystal lattice. Okay, now in this case, omega is given to you. So what will happen? Omega is given to you, then you have to consider what? You have to just compare this one with the standard expression we are going to have. So if I'm going to talk about the standard omega expression in this particular situation of 1D monoatomic lattice vibration, it is going to be having, you can say 4c over 2m as a c as a constant. Even it can be any other term we can take there, but I'm going to take it as 4c over m, right? And then sine ka over 2. So they have asked you for the force constant. I have taken this c as a constant here. Okay, then when you will compare it with the a, what you will get as the value of c, that will be a square m divided by 4. So that's your option A, which is the correct one here. Okay, this is the way you will be solving it. For solving this part, if you know or you have memorized the standard expression, it will be quite easy for you to work on it. But if you don't know about that, you have difficulty in recalling it, then you may have difficulty in solving it too. So it depends. If it's clear, guys, I'm going to take the next question now, which is here. A lattice has the following primitive vectors. The reciprocal lattice corresponding to the above lattice is. Options are BCC lattice with the cube edge of pi by 2 angstrom inverse, BCC lattice with cube edge of 2 pi angstrom inverse, option C says FCC lattice with cube edge of pi by 2 angstrom inverse. And option D I'll write on the next slide, guys. FCC lattice with cube edge of 2 pi angstrom inverse. Okay, that's what you're gonna have. Now you have to try it. So they have given you the primitive lattice vectors, small a, b and c, and then they are asking you for the reciprocal lattice, what will be the type of lattice you will have and what will be its cube edge. So that's what we have to work on. So when we will find the vector capital A, which will be for reciprocal lattice, you will have 2 pi b cross c divided by a dot b cross c. And then for b, it will be 2 pi and multiplied with it's b you are finding, so c cross a divided by a dot b cross c. So denominator is remaining same in all the cases, but your numerator part is changing. So let me just show you the formula. That's going to be 2 pi A expression you're writing, so B cross C here. And then A dot B cross C. Okay, the next one B, then it should be 2 pi C cross A. The next one, it will be A dot B cross C. Next one, it's going to be vector C, that's going to be 2 pi, and it's going to be your C cross A. You have written A cross B. So A dot B cross C. That's what you will have, right? In this case, you just have to plug in the given values of A, B, and C. So depending on what values are given, you will just find their cross product. I'm gonna wait for your reply. If you're gonna get the answer now just by plugging in the values, that's great. If you will have difficulty, you can tell me. I'll go ahead with that discussion. So let me know if you want me to discuss it, or is that clear? So once you're going to find vector A, the capital A, I think you will have something similar to what I'm going to write. But if it is different for you, you can tell me. Negative I plus j plus k cap and A naught inverse. Then for B, you will have pi by 2 I minus j plus k cap. Also guys, the type of expression they have given you, it was showing you it is face-centered cubic, right? If you are familiar with the expressions for the lattice vectors, so you will easily get able to know like, oh, it's similar to the FCC, the one which is given, and this one which you are getting is for BCC. Why? Because the reciprocal lattice of FCC lattice is nothing but it is BCC. So that's how even you need to know the forms of the vectors, because that will be helping you to identify the type of lattice you are getting. Okay, so you are getting BCC with what? With the FCC. So when FCC lattice is given, its reciprocal lattice is BCC. That's how you can find it. Okay, so your option A is the correct one, which is saying BCC lattice with cube edge of pi by 2 angstrom inverse. Okay, that's how you can find it. Let me know if in case there is anybody having any doubt, but if it is clear, I'll give you the next question. If you have any question, query, or doubt, or something you want to ask, you can surely mention it, guys. Otherwise, next question is waiting for you. The question is, the dispersion relation I'm just going to write it, guys. The dispersion relation for phonons in a one-dimensional monoatomic Bravais lattice with lattice spacing A and consisting of ions of masses m is given by omega k is equal to square root 2c by m 1 minus cos ka where omega is the frequency of oscillation k is the wave vector and c is the spring constant. For the long wavelength, mods, that is lambda is very much greater than a, the ratio of the phase velocity to the group velocity is. Options are 1, 2, 3 or 4. That's what you have to consider, guys, and tell me what do you think is the right answer according to you. If you're not gonna get it, we will talk about that one, like how to solve this one, this type of questions. If you will get it, then that's great. Try it now and let me know what is the right answer according to you. So actually the omega is given to you. You need to know what is the group velocity and what is the phase velocity formula. So group velocity is d omega over dk divided by dk, means differentiation of omega with respect to k, and the phase velocity is simply omega over k. But if you will see, they are asking for long wavelength. Long wavelength means the k will be small. For a smaller value of k, we can write the cos ka or cos theta. For a smaller theta is 1 minus theta square over 2. So that will be k square over 2 because 1 will get cancelled out. So when you will get k square over 2, 2 and 2 will get cancelled out. You will just have root c over m ka. This is what you will have right now. You can even have a look at this and tell me if you're gonna get it or not. If you will find d omega by dk, that is the group velocity from this expression, and omega by k, that is the phase velocity from this expression, you will find that both are gonna be same and the ratio will be equal to 1. Hence, you're gonna get the option A to be the correct one. Okay guys, that's how you can solve this type of questions. But in case if you're gonna have any doubt anywhere, you can surely let me know about it and we can consider that part. But if it is clear, that's great, great, great. Let's take the next one then. The energy dispersion for electrons in one dimensional lattice, 1 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 dimensional with lattice parameter A is given by Ek, that is equal to E naught minus 1 over 2 W cos Ka, where W and E naught are constants the effective mass of the electron near the bottom of the band is, options are 2h squared square over WA square, h squared square over WA square, h squared square over 2WA square, and the last one is h squared square over 4WA square. Try it now and let me know if in case there is anybody having any doubt. We can talk about it then. Try it now. So in this case, you have to find the effective mass of the electron near the bottom of the band, right? Effective mass formula, what is that? Like, that's what you need to recall first of all. It is m star is equal to h squared square over d2e over dk square, right? And once you're going to consider it near the bottom of the band, means k tending to 0. It's not equal to 0, it's just tending to 0. When it is tending to 0, cos ka can be related as 1 minus theta square over a, which is ka square over a. So once you will write that part, if you're going to differentiate the given energy with respect to k, and that's to twice, you will be having just the 2k initially, then 2a square. So that's 2 will get cancelled out, WA square you will have at this place. So h squared square over WA square, which is option, which one? It's simply you are going to get same as, let's see, did we miss something or did we write everything? So ka square over 2 we will also have here, guys, okay, because 1 minus theta square over 2. So in that case, you will get 2h squared square over WA square. Let me just show you. So h squared square, and when you are differentiating it twice with respect to k, so it will give you 2k, and then just 2, the k part will get like differentiated. So 2a square divided by 2, 2 cancelled out, WA square, this 2 is in the denominator, so that will give you 2 h squared square over WA square, which is your option A, and that is the correct option. Please tell me if in case there is anybody having any doubt, we can talk about it. But if it is getting clear, then that's great. We are ready to take one more question. Okay, and if there is someone like having any kind of doubt in this part, just mention it. Otherwise, your next question is the energy wave vector, that is Ek dispersion relation for a particle in 2 dimensions is E is equal to Ck where C is a constant. If its density of states dE is proportional to e to the power p, then the value of p is options are 1, 2, 3 and 4. Try it now and let me know what do you think is the right answer, and if you are getting it, that's great. If you are not getting it, I'll help you to find that answer or to know how to find it. The energy wave vector dispersion relation for a particle in 2 dimensions is E is equal to Ck, where C is a constant if its density of states is proportional to e to the power p. So how, as per the energy and k relation or energy dependency on k, you can find the density of states dependency? Okay, that's what you have to see. Try. Now let me know as you will get it done. Okay guys, so let me just tell you, there is a trick to solve such type of questions. Whenever you know how the E depends on K, like E is proportional to K to the power S, in that case, your density of states will be dependent on E, as dE will be proportional to e to the power d by S minus 1. Okay, so d is what? The dimension. S is what? The power of K. You are having the E dependency on K. So that's 1 divided by 2 divided by 1, because dimension 2 dimension, so these 2 and S 1, so 2 minus 1 is 1. It's just dependent on e to the power 1, which is going to be your p value 1. So this is something you need to know to solve such type of questions, and I think now you are going to find it easy once you got to know about this part. If in case still there is anybody having any doubt, you can just mention it. We will be talking about that part, guys, but if it's clear, I'm going to write the next question. This is the latest offer slide. It is just valid till 12th August. To grab this offer, you can use and apply the code Anjali A Live, okay, to get the discount in the total subscription amount. I'll write the next question now. It's here, guys. In a certain two-dimensional lattice the energy dispersion of the electrons is epsilon vector k, that is equal to negative 2t cos kxa plus 2 cos half kxa cos root 3 by 2 k by a. That's what you're gonna have. Oh, let me just check, is it same? Yeah, it's same. And then where vector k is equal to as a function of kx and ky, it denotes the wave vector. A is the lattice constant and T is a constant in units of electron volts in this lattice. The effective mass tensor Mij of electrons calculated at the center of the Brillouin zone has the form Mij, which is equal to h² over Ta square alpha 0 0 alpha. The value of alpha is, options are in this case. What will happen in this case? They have given you the energy dispersion relation, and then they have given you the format for the, or the kind of form for the effective mass, right? So in this case, what will happen? In this case, you have to find the effective mass tensor first of all. When you will work on finding the effective mass tensor, you will take the steps like you have to form the tensor here. So how to form the tensor? Tensor is basically the kind of matrix. It's 2 by 2 order or 3 by 3 order. We have to see x and y are involved here, right? So 2 by 2 order. What we have to do? We are just going to write mxx star here, that's effective mass, so star, mxy star here, which is first row, second column, first row and second column, right? This is going to be second row, first column, second row, second column, right? That's how you have to consider it. So this is your effective mass tensor. Now what is effective mass? Basically when you will consider mxx star, so in that case it shows h² over delta to E over delta kx square, right? And when you will consider h² star over Or I would say even you can write it this way, delta kx, h square over delta to e over delta kx, delta ky. That's your mxy star. Then this third one is h square over delta to e over delta ky and delta kx. H square over delta to e delta ky and delta ky. This is what you will have. So what you have to do, you have to just plug in the values at the various places depending on at which position you are considering it. And if they're talking about at the center of the Brilliant Zone, like here, at the center. So at the center means exactly you have to plug in the value of k to be equal to 0. So what you will do, just plug in k is equal to 0 and you will be able to get the answer, right? So this kind of matrix you will form, then do the comparison with the given matrix and then get your final answer. That's what you have to do, guys. So what we are going to do, once you will do it, you are going to get answer closest to 0.333 and that's your right answer too. What we will do, we are going to keep it this much right now in this session. Quickly, let me just show you the latest offer slide, which is this one. The offer is just valid till 12th August and to grab this offer, you can use and apply the code Anjali Live as mentioned here on the screen to grab this offer and to get the discount in the total subscription amount. Also, guys, here is a slide which is going to show you the difference between plus iconic and the light subscription. Depending on whichever you find more beneficial for yourself, you can take that subscription. And whenever you will go ahead to take the subscription, use and apply the code Anjali Live to get the discount in the total subscription amount. Thank you so much everyone for joining this session and for attending it till the end. Thank you. Bye.